Well, hello, it's Doug Lucas. I'm speaking to you today from Emerald Hills, Team Expansion's home base on the outskirts of Louisville, Kentucky. And we're here looking toward the heavenlies, Emerald Hills skies. And we'd like to welcome you tonight. The last half an hour before kicking one of these things off is for me somewhat of a stressful experience trying to get everything ready. I never know for sure if everything's going to work. If you are there and you're listening, would you mind saying hello and let us know that we're coming through? I'm going to try to log on to the uh, live stream with my phone, and that way, hopefully, I can try to see what you're seeing. And just going to make sure we have, yeah, so I can see, I think I can hear audio there, and looks like everything is running okay, and I can see your chat. So I'm gonna try to get going here. Let's just say a brief word about the tools that we're using. The first thing I should tell you about is this targeting software. This enables us to make a list of the things we'd like to see, and it kind of gives us a to-do list for the night, you could say, I guess. It's called Astro Planner, and it's really exceptional at helping us find all these deep space objects and targets that we might want to go look at. The second thing I'll mention is our planetarium program, and we use Sky Safari. I've mentioned it before. It's a little bit unique because Sky Safari is, I think, for me anyway, for my uses, it's the best planetarium software, but it's not available in Windows, and we happen to be running on a Windows platform. So unfortunately, that means that we have to find another way. Well, it happens that it's available in Android, not Windows, but they do it in Android. So, and of course, iOS. By the way, if I had an Apple, everything would be all right when it comes to Sky Safari, but I don't. And so what we do is we run an emulator so that it can pretend to be Android inside of a Windows machine, and then we boot up Sky Safari inside of that. So that'll be our planetarium software for the night, and that just lets us see kind of the sky as we should be seeing it. The third tool that we'll be using is an application called SharpCap. It's probably the most well-known EAA software, electronically assisted astronomy software. It's kind of a photographic astrophotography specialized program that allows you to observe the night skies. So we've got SharpCap, I hope, booted up there, and I think you can see that. And then the fourth thing that we sometimes let you see is the actual telescope outside. And I think if you look very carefully, you can actually see uh, a little bit of the scope there, can't you? In the webcam, it's just barely silhouetted there, isn't it? I'll I'll shine a little bit more light on the scope so you can see it. Our optical tube assembly, let me see if I can brighten that up some. There we go. Our optical tube assembly is made by Celestron, and it is called a RASA, a Roe Ackerman Schmidt astrograph. Has a dew shield on the front of it. The black section is a dew shield. And inside of that front section, there is a camera. It says WOA ASI. It's a 2600 MC Pro. And then it's mounted on a Skywatcher mount. And you can see the cables come inside to the final part of the gear before we get to the laptop. And that is the we're able to use a truck. And so we're actually operating from within the back of a Ford Expedition. That's kind of a part of our gear as well. And then we also run a Windows laptop that you're watching in. Final thing I'll mention is just the thing we use to point the scope. It's basically a kind of server inside of your operating system that lets the telescope and the mount. It lets the mount talk to the computer and it talks to the mount and so forth. That little graphic you see on the right is a picture, a 3D picture of what the telescope looks like, so you can kind of tell where the mount is in relation to the world. And this server is not the most common one, but it's the one I like the best. It's called Green Swamp Server. So we have that running as well. It's almost dark. Let's go back to uh, our I don't know. It's still saying it's restricted, I guess, because it's saying it's not all the way dark yet. But let's try to go there anyway. What we're going to try to do then is connect our, yeah, there we go. You heard the server talking to this software for some reason. Oh, I know why it's not letting us through there yet, is because it still thinks that it's restricted. It doesn't think it's dark enough yet. So we're going to go over here to our planetarium program and we're going to search for our first target, which was M33, I think. And you can see it's the pinwheel galaxy. Some people call it triangulum, the triangulum galaxy. And what we'll do is we'll center that. So that kind of gives us an idea of where, oh, look, the International Space Station is rising. Let's see if we can, rats, I missed it there. That would have been interesting. I just didn't click fast enough, did I? If I go ISS, does it let me choose that and then say center? That would have been interesting if we could see that rise. Let's try that again. It's thinking that it's still underneath the horizon. What you're looking at now is the horizon of our. Maybe it gave me a little heads up. How about that? That would be interesting, wouldn't it? Let's try to go to that and just see what happens. That'd be interesting if we could see the International Space Station. And man, what if it would keep track of it? I've never tried this. There it is rising. Let me first of all look and see what you're looking at. I should check that first. Oh, you're still looking at the targeting software. Let me just let you see the planetarium software first. Now let's go over and let you see the put you in sharp cap. Look at that. Um, let's go like this. Probably I've never tried to do this before. Let's give ourselves a little bit more time. Let's give ourselves maybe 4-second exposures. I think we're still in the trees over there. There you can see the trees. You can make out the trees there. Let's, by the time, I just don't know how you catch it. This is fascinating. Never tried to do this before. Ah, see that little, that little moving line? That's the International Space Station. We're just chasing it across the sky. Look at that. That line that you see is the International Space Station. And unfortunately, we don't have tracking designed to help us stay up with it. So we're not able to actually track with it like you can track with a star. But but it's trying, isn't it? So you can tell people that you saw the International Space Station as a trailing slash in the scope view. How about that? Well, I don't know how to make that. I don't know how to make that. I don't know how to stay up with it any better than what we are. So it's kind of a wild goose chase, but it was fun, wasn't it? It just looks like because our scope is constantly trying to chase it. It's moving across the sky fast enough that we can't keep up. How about that? Isn't that interesting? I'm going to look and see if there are any comments there. Well, you're seeing that I can see on my phone. All right. Well, that was uh, a nice little exercise there. Now let's go back to what we were originally going to do. Let's go to M33. Okay, now we can use our targeting software. It has decided that it's dark enough. So what we do is we pick out a target in our targeting software, and then we do what's called slew there. And of course, slewing is just a fancy name for go to. Um, just see how we're doing there. What I can do is I can shine a flashlight out the window. I should show you there. I kind of look out the window. I don't know if you're. I think what we're going to do is going to remove that and re-add it because that's not a live view of the webcam. I think I'm going to re-add a view of the webcam. We're gonna say window capture. Um, let's see, what do we use for the webcam? A video capture device, scope cam, let's call it. And now we're going to try to pick out the. Oh, you know what? We don't have the scope cam plugged in. That's probably why I couldn't find it, huh? Let's plug that in and try that again. Let's see. So we're gonna take that away and try to add that again. A video capture device, scope, not the mouthwash. And then it's going to let us choose a window, and this time we'll hopefully choose the window. And I'm going to make that a little bit bigger and then just center it there in your frame. And then what I'll do is I'll point outside the window. So there the scope is pointed hopefully at M33. So you can see it out the window there. Now let's go back to Sky Safari for just a second. And let's find M33 here in Sky Safari so we kind of know what we're looking at. M33, and then we'll center on that. So you can see it's got the field of view already identified. It knows where the telescope is pointing, in other words. You can see we should be right on the Pinwheel Galaxy, according to what the planetarium thinks. So that's a good thing. And that's the Pinwheel Galaxy we're trying to find. Man, it's going to be beautiful if we can make it look anything like that. What is this? That looks like NGC 604. A couple of stars there. I don't know what that is. NGC 592 is just letting us know what some of the stars are. Okay, so let's put you now back over in SharpCap, and then I'll join you in SharpCap. Oh, that's a really a good start in SharpCap, isn't it? Got a good bunch of stars there. Now SharpCap should have paid attention to what we wanted to point to, and it was listening when we said let's go to M33. So what SharpCap does is it says, oh, you want the location for M33? Let me see if I can look at the stars that the telescope is seeing, and I'll try to figure out if that's really what you wanted to see. And you can see that it did find a match in its database with the set of stars that the telescope was viewing. And now what it's doing, it's making a final adjustment. You can see we were off about 1.76 degrees, and that's not uncommon with our first object. And what it's doing is it's trying to recenter on M33 so that it will be more exact. And there, now it thinks we're recentered. So what we want to do now is let's get our camera and see what we're pointing on our camera. Let's take that down to about a -8 on our camera temperature. And the reason we pay attention to our camera temperature is really twofold. First, by keeping the camera really cold, we are able to minimize the chance that the camera will have those hot pixels from pixels that are inside, little pieces that are inside the chip that might overcook. So we minimize that. And then the second thing we do is we make sure everything is always consistent. You want your imaging train to always be consistent. And right now we have a lot of gain here. We were doing that during the polar alignment. Let's bring this gain down, if we can, to about 100. And I think that means we're going to have to move our exposure up to maybe 10-second exposures. Let's see what we get. So what we're trying to do right now is just get a pretty good picture of the sky. And what our software does here, it brings in two kind of calibration frames here in the lower right. It brings in a calibration frame that we've captured called a dark frame, and then one that we've captured called a flat frame. And what those do is try to take care of any of the problems that might be in our picture. Now what we'll do is we'll reset this display histogram, and that tries to kind of get a fresh start on the view, but boy, it doesn't look like we have a good enough doesn't look like we have a long enough exposure, does it? Because we're not really seeing enough stars there in the picture, I don't think. So we'll make our gain 200. Now we're seeing a few more stars. I wondered if we could to keep our exposure low, like around the 10-second range. And that allows us to see the picture a little more real time. So now we'll reset this display histogram again. And I think we've probably got enough now that we can start live stacking. And what live stacking does, it starts taking those 10-second pictures. And if you could look over here on the lower left-hand side, I don't think my mouse does a good job gesturing at things in this program. I've kind of noticed before, if I try to point at something, I think my mouse, I'm going to watch the webcam, my phone for a second and see. Yeah, my mouse doesn't point exactly enough so I can show you what I'm looking at. But what I'm looking at in this lower left-hand side is what they call the live stack menu. And down there in the lower left, you might be able to read frames stacked. And we're up to about 3 now. And because of the way the resolution works out, you can't really see what my mouse is pointing at. There are 4 frames, and what this says is, how many do we have to ignore? And it says 0. So now what we do is we reset the histogram that we're going to get our image from, and we pull our black level over here just right around those peaks somewhere, and just to get us started, we reset our color on the basis of the display, the histogram here too. And then we start moving this mid-level over till we can start to see what we're looking at here in the picture. And sure enough, you can see we're barely starting to see M33 right there. And playing with this black level first allows us to set the tone of the night sky. And it just depends on how much glow you want in the night sky. And we've still got a little bit of city glow in there. We are running a filter. It's the Celestron light pollution filter that's sort of made to match the kind of telescope we have. They kind of, in a way, they made them to match together. The RASA telescope, this light pollution filter is made to kind of maximize its ability in a night sky near a city. So we'll kind of set that so there's a little glow, but not much. And then we'll bring this, you see the white level is still over here to the right. I think that's okay. We can maybe bring that white level in a little bit. You can see it just gives us a little too much glow though, doesn't it? And now this mid-level, we'll play with it a bunch until we start to get that M33 visible. Now what we can do, we can zoom in on our M33, and I don't know what's going to be a good amount of zoom here. Let's start out right about here. Now you can start to see M33 forming up there. Now, just for a second while that's forming up, let's go back for a moment over to our Planetarium software. And the reason why I like to do this, I like to kind of see where I'm looking in the night sky so I don't lose track of where we are. I mean, it's tempting when you're using EAA software like we are. It's tempting to kind of say, well, we really don't need this because after all, we're not really we don't really have to stand outside and look at the night sky. But you see, I think we do. We want to be able to see where we're viewing. And if you can look, let me just come in a little bit here and then hop up a little. You can see that this uh, green line, it matches up with the meridian. So it's on the polar star. And then as you start to shift over here, you start to see, I don't know if you're recognizing any of this night sky. That's that great square of Pegasus. Here's the constellation Pisces. There's Cetus, and there's Aries, Triangulum. This is probably not a real well-known part of the night sky, but here's something you'd know: Cassiopeia. See that W there? So if you can imagine in your night sky and imagine this W, if you can look up in your night sky and find that W of Cassiopeia and go away from the open part of the W. So if you think of Cassiopeia as a W, go to the back side, but maybe don't go all the way, to the North Pole area. We're just pointing away from the backside, and that's kind of the part of the sky that we're looking in right now to CM33. Let's go back to our sharp cap window and just look one more time what we're doing. Now, why do we do this live stacking? Well, this enables our software to allow us to accent the part that we want to see, and it starts dropping out the part that we don't. That's what this is all about. So I think with this galaxy, for example, you can start to see, look at this trailing arm. That's barely visible, a trailing arm that's coming out. You know what I'm going to do is just take that away for a minute and kind of make this a little bit bigger so you can see just a little more. This new 2600 camera that we have gives us a little more ability to zoom in and keep our pixels sharp. So look at that arm, the way it's kind of flinging out. That's why they call it pinwheel, you might say. And whenever I'm looking at a galaxy like this, I just love to kind of imagine what is it like to live in that galaxy? What is that like? I mean, we live in the Milky Way galaxy, but what is it like to live in this galaxy? And I'm going to play, if I can pull it off. Let me see if I can make all the right connections. I'm going to unmute the computer audio for a second, and I'm going to mute my headset. I'm going to see if I can play this audio tour for you. Okay, I'm going to turn my headset back on. I think it's kind of fun to learn about these galaxies and put this all together. Um, Imagine living. Now you can see that bright core, can't you? See that bright star in the middle? That's kind of like the gravitational hub of that galaxy. Uh, they say that this galaxy was first identified by a guy in 1654, if you can imagine it, and he uh, he then got attention of Charles Messier in 1764 when he cataloged it in his list, And you might remember that Charles Messier was trying to make a list of the things that wouldn't get in his way. He was actually looking for comets. So he made a list of all the things that wouldn't distract him. But in doing so, he created what is arguably the most well-known list of deep space objects, and he called it M33. Nobody ever wrote about this galaxy until the telescope was invented. And that's probably not too surprising, is it? Because it's pretty hard to see. Uh, but by the time we get to the 1780s and Herschel, he was starting to see it a little more clearly. And of course, he began to theorize that this was outside the Milky Way. Sometimes people call it the Pinwheel Galaxy. And interestingly, in its name, Triangulum, it's actually mentioned in Star Trek Next Generation in an episode that's entitled Where No One Has Gone Before. And it's the galaxy that the Enterprise travels to when it's got some kind of malfunction. And the malfunction actually trips up and boosts its warp speed. And when that happens, it actually goes to this galaxy, Triangulum. That's kind of interesting that you're able to see it with your own eyes now. What we're going to do is we're going to probably just make one last decision as to where we like this. And this is where you guys can help me if you want to comment there. I'm not really good on my colors and all, so I sometimes don't know what to do with this because um, I'm not as good of I don't have as good a perception on things like green. I guess I'm red-green colorblind. So I think I'm just gonna put the white level over there. Let me make sure you guys are looking at the right thing here. Yeah, you're looking at sharp cap too. I think I'm gonna try playing with this black level just again and make sure that we're squeezing as much as we can out of that black. Looks like we are. Now let's see if we can get a little bit more of those arms. Just depends on how much glow you want in this picture. It's actually very interesting, isn't it? To see another galaxy in such detail that we can actually see this spiral arm starting to throw dust and star material out because it's spinning so rapidly and powerfully. Okay, let's hold it up there then. Oh, I didn't give us a name. I didn't name it. So help me remember. I need to make sure I do that name before we start live stacking. I don't think right now it'll do any good to name it. So it'll save it with some nondescript name, and I'll have to save the name later. We're going to save it exactly as we've seen it, and it's waiting for that next snapshot. Okay, we're going to stop live stacking and take one last look before it disappears. And then we're going to go back to our targeting software. So I'm going to put you guys back in Astroplanner, and I'm going to go back there too. And I'm just going to quickly say, make a new observation of this. I'm going to say, amazing that we could see spiral arms throwing stardust out into open space. Something like that. Just enough to... Now let's go here where it says attachments, and let's go look for this attachment. Like I say, it's going to be a little harder to find because it will have saved it in some nondescript file name, and next time we'll catch up. And there's our picture. So now we've got a picture associated with this object, and it's saved it, and now we're done. Okay, let's go see if we can find Uranus. So we're going to say slew to Uranus. Now before I do that, I'm going to make it so that you can see the scope as it slews. I like to do that at least the first few times so you get a sense of the rhythm. So I'm going to go back over here now in the scope cam window and light up that scope for you. And you can see a gearbox down there where we stow some of our gear. So now, while you're looking at that, I'm going to go back over to the scope, and I'm going to say, let's slew to Uranus. So now you can see the scope moving. Now Uranus is way out there, as you know. What is it? The the next to the last of the planets that we now call planets. I mean, it depends on whether you want to call Pluto a planet. Most people don't anymore. Let's go over to our planetarium software. By the way, thanks for those of you who are out there. If you'd like to ever chat something in there, you're welcome to do that, just to say hello. But I appreciate you being with me here tonight. It kind of makes it less lonely, the fact that you're there with us. We're going to go to find Uranus here in our planetarium program. Uranus. And let's center on it. So you can see right there is our field of view. What the planetarium program tries to do is it tries to let us see what is the telescope seeing. So we're going to zero in, and then you can see that in our field of view, that's what Uranus is going to look like, and that's it. In other words, with a rich field telescope like this that sees, what are we looking at here? Probably 3 degrees of the night sky. Basically, this thing is barely going to look as a disk, if that. It's just going to be a dot. So let's get an idea of the star patterns here, and that'll hopefully tell us what to look for. So let's try to decide. Now, this is an interesting little pattern here, isn't it? 3 little stars and kind of a parachute. That might help us. And then there's a little bit brighter one here, but boy, it doesn't help me much to say brighter because there's nothing really compare. What else could we look at that's interesting? Here is 1 star and 2 stars that kind of point at Uranus, and they kind of point at their parachute. That's not very good, is it? Not a very good landmark. Let's go over to our sharp cap window now, and I'll join you there. And the first thing we want to do is name this Uranus. And let's use our reset, and let's do our plate solve and resync. And what that'll do, it'll say, oh, so you wanted to see Uranus, huh? And then it'll let us know how close we really are, because like I say, it's comparing what we really see with what its database tells us that we should be seeing if we were pointing in Uranus. If it doesn't work, we were just, what is that? Is that 4? See, that would be 4/10 of a degree. Is that right? So that's 4. Is that right? We were within 4/100ths of a degree. So we were pretty spot on. And then right here, you can see our scope has settled down. I think this is going to be Uranus right there, but let's reset this again. I don't really like that. I see. We're not on our auto, are we? Let's go back out to our auto view. That's not a really good picture of a lot of stars, is it? Wow, are we going to have to go to 20 seconds? I'm afraid we are to see a lot. Let's go to 20 seconds. Now that's with a gain of 200. I like to keep that gain low. There's 7 of you now there. Thanks for joining us. You're welcome to say hi anytime you want. And that way we know you're there. But thank you for being there anyway. There, now we're seeing a few more stars. Boy, in our field, we are not seeing quite yet what we're seeing in the, let's go to 30 seconds at 200. In fact, let's just live dangerously and make this 300 for a second. And that way we're going to see a lot of stars because we want to try to find our object. And boy, wouldn't it be great if it were right there in the middle? That's what we really wish we would find, is that it's right there in the middle. So what's happening right now is our SharpCap software is taking a 30-second picture of the sky. And when it does, it's going to let us see a lot more. And what we want to do is we want to make sure we're framed up correctly before we start our live stacking. Now, if we were in luck, remember in our planetarium software, first of all, our object would be right in the middle. There is that. And then look at this. I think this is our parachute. And then here's our 1 with our 1, 2. So what I saw, I saw this star with these two stars that were pointing in the basic direction of Uranus. And then I saw this little parachute looking thing with a little picture here. That's what I try to do. And right in the middle is Uranus. So that's our object. So this is a good view of our object. Let's do our reset and start live stacking. I don't know how much we're going to get with live stacking, honestly. We're going to clear out our previous image, and it's going to start live stacking for us. And what we have to do at 30 seconds, the reason we have to make it a little longer exposure is because we're really not seeing a deep space object in this case that has any mass at all. We're looking at, a dot basically in the night sky. So I kind of think it would be good if we were to kind of listen to that. Oh my goodness, that is extremely bright now, isn't it? So let's back this gain back down to 200. Sorry, that's way too bright. I just gave it too much gas. We gave it too much gas. And we're going to let that 30 seconds go by at 200 gain. See if that gets us a little more in the right ballpark. With that first exposure, I'm interested to see how this plays out when we are live stacking. Let's do our reset now and see if it straightens that out. Is that first one just blinding us? So we're going to have to reset the entire live stack. Let's go down here and reset this stack and do an auto stretch there. Let's reset our color. By the way, you can see some vignetting when we do our auto stretch. You can see some vignetting, and that's just because what we did is we ordered a camera that would see the entire width of our light that's spilling on our sensor. We did that on purpose so we could eke out every bit of our light. So these are bits in the corner where the telescope is not spilling light onto the sensor. So in a way, it's not vignetting. It's just not getting light there. And I kind of like that because it lets us see as much of the night sky as we can using this approach. Let's bring our white level back up to there. Make this night sky a little bit darker. I like where the black is. And let's just leave our mids right around there some. Now, with that live stacking for a moment, let me just go over here and turn on the desktop audio again, and I'm going to mute my headset mic.
Uranus was the first planet to be discovered and marked the beginning of the career of the great astronomer William Herschel. This remote world orbits the Sun at 19 times the distance from the Sun to our Earth. Cold and remote Uranus was named for the ancient god who was the father of the gods. In a telescope, Uranus appears pale green, not blue as shown in most photos. In a 63-centimeter reflector, it is a tiny ball with no markings visible. Sometimes, however, Uranus differs in brightness from its published value of about magnitude 5.7. It could be that clouds of the kind seen on neighboring Neptune by the Voyager spacecraft obscure and cause Uranus to fluctuate like a variable star. More work is needed to sort this out. Herschel discovered Uranus in 1781 while conducting a survey, the first, of the sky. He examined each star as it came into the field of his telescope and noted details such as position, color, and if the star was single or a double. In the spring of that year, he spotted Uranus high in the constellation Gemini. He noted that the star was absent from his sky map, and upon looking with differing powers, he saw the disk grow or shrink in proportion to the magnification. Stars will not do this, since they are too far off to be magnified in size. Herschel thought he had found a comet and reported the discovery. When the orbit was derived, it turned out to be another planet, the first ever found. The poet Keats mentions this in the lines, "Then I felt like some watcher of the skies when a new planet swims into his ken." Herschel became famous, and the new planet's discovery allowed him to set up a telescope-building facility. At that time, he made the largest telescopes in the world. As for Uranus, modern observers and spacecraft show a cold and hostile world, a gas planet that is tipped over on its side relative to the flat plane of the solar system. Uranus also has a ring system like neighboring Saturn, but very faint. The system was reported by Herschel, but no later observer was skillful enough to see it, and its existence was written off as a mistake. Then, in the 1970s, it was rediscovered by a powerful telescope lifted high above the clouds in an aircraft. It's a tribute to Herschel's skill that it took an aircraft-mounted telescope to approach his accuracy. Uranus has at least 24 little moons. By tradition, they are named after the characters in the Shakespeare play The Tempest. Thus we meet Prospero, Caliban, Ariel, and so on.
We are zoomed way in, and what you can see, and mute the desktop audio again so I don't echo, what you can see because we're zoomed in is exactly what the guy was talking about. That this turns into a disk when we zoom in closely. Now I want to point something else out. If you look very close, can you see these little dots here? Look at the little dot on each side of Uranus. I'm going to try to go in a little bit closer here. Now we're starting to pixelate. See, now we're getting to the limit of even this camera. Even though this is a high-res camera, we're getting to its limit. Look at those little dots on either side of Uranus. Now, you know what's interesting? Those are two of Uranus's moons. But the sad thing is, we're not actually seeing individual moons when we look at those two dots on either side. What you're seeing is the amalgamation of several moons. Tonight, for example, we know that Umbriel and the moon called Titania, they're on one side of Uranus. And then on the other side of Uranus, we're able to see a moon called Oberon, and we're also able to see a moon called Ariel. So that's what those are on either side of Uranus. You're actually looking at the moons of Uranus there, but they're not super clear because they're kind of made into two little dots instead of one. Now it looks like, I don't know, see how that star here to the left, make sure you're looking at the right thing here. I'm going to go back over and, yeah, you're looking at see how this star over here on the left has just a tiny little dot in the middle of it. What that means is I could adjust the focus just a smidgen. I mean, we're zoomed in so close that, I mean, I would just have to touch the focus. And by the way, this coming week, a focusing motor comes in so that remotely I'll be able to focus the telescope. And that's when it'll really come in handy. At a time like this, we'll be able to just barely touch up that focus now so that these stars are pinpoint, and that might help us. But right there, you can just barely see two moons. You know what? I'm going to throw it a little bit mosaic-y here so that you can see what I mean. Can you see now? Let me just let you live really dangerously. I'm going to make it 150%. Look how there are two things there instead of one. Those are the two moons on that side of Uranus. And that's why those moons of Uranus are kind of, not making that pinpoint look, because they're sort of showing us two moons at once. I think that's interesting to be able to see, not just see the planet Uranus tonight, but be able to see the moons of Uranus, especially since this focus isn't perfect. I could hop out and we could play with that focus, couldn't we? What I would have to do is take my laptop outside, and what I have to do is actually take it out to the telescope. Is that worth it, or what do you think? Somebody tell me if you're willing. I'm looking here on my phone and nobody's said anything yet. You guys are a quiet bunch. 7 of you there. Actually, I think I'm one of the 7, so there are really only 6 of you there. But if one of you wants to tell me, should I go out and play with that focus and we see if we can sharpen this up any? Or do you think, just top down for a bit, always makes me want to sing Starry, Starry Night. I think that's probably Tim. You know, I do the same thing, and Penny, my wife, she says, why do you keep singing that song? Because of this very thing. So somebody tell me if I should hop out, or should we not waste time on that focus? I'm telling you, I think we could get it a little closer based on that. Let's don't waste time on it, because this is the most that we'll probably zero in, I bet. But on another night, the next time we meet, I'll have that focusing motor, and we won't have to trail the laptop out of the truck and take it out by the scope and use the focuser on the scope, because we'll have the remote focusing capability. So for right now, let's just let you know you have now seen Uranus, And you can see even the color matches up with what the guy said in the narration. Let me do one last color balance here. So you're seeing as close as possible with the real colors. And then let's bring that mid-level in just a little bit. Now, once again, you're only able to see this as a disk because of how much our 8-inch RASA scope is zeroing in. If you want to look up in the night sky, that's what you'll actually see. And so let's just appreciate just for a second that dot in the middle of this picture, that dot that you see there is Uranus. And when you look up in the night sky, it's not even, to be honest, it's not even a particularly bright star. It looks fairly bright, doesn't it, uh, in our view there? But it is not. It's a magnitude. Get this. It's a magnitude of 14. Oh wait, I'm on Ariel. I was going to say I didn't think. Let me go back to. Let me go back to Uranus. I'm telling you that that moon is a 14. But if we go back to Uranus, which is right there, and then let's go, and I can tell you exactly how bright it is. It's a magnitude of almost 6. So it is at the visual limit of our eyes in a night sky that's clear. In a Louisville night sky that has the dome of light, you wouldn't even see it. So just take a gander at that and realize how lucky we are to be able to see this disk here and appreciate that's what we would see if we would fly out to Uranus. You know, one more thing I'd like for us to do. Let's go back one more time to our planetarium software, and let's get rid of that scope panel for a second. And there you see those moons that we were looking at. There's Umbriel, and there's Ariel and Oberon. Let's broaden way out, and let's do this. Let's orbit the object. So we're going to actually now in our planetarium software. Oh, we can't do that while we're connected to a telescope. Never mind. We're not going to mess with that. But a planetarium software has some neat effects, and I thought that might be cool to. But let's don't mess with it. Okay, so we're ready to go back to our targeting software and make our quick note in our observation. So we're going to say a new observation, and we saw moons on either side of Uranus. Actually, we saw specks that we're just going to say nearly merge. We could almost pick them apart together. Amazed that we could pick those moons out of the night sky. And then I'm just going to say, go to the, oh, we haven't taken our picture yet, have we? Let's go back to our sharp cap real quick, and I'm going to take our picture here so that we can, okay, so that's captured. Now what we'll do is we'll go add that picture, and we're going to copy the file into the attachment database. We're going to go back to here, and now we can tell in real life it says Uranus. And such as it is, that little dot in the middle, that's Uranus. All right, let's head for M74. I won't try to make you go look at the scope every time. Let's go over to Sharp Cap, and in Sharp Cap, oh, we got to stop our live stacking. And in Sharp Cap, let's go back out to Auto, the full view, and let's change this to our new target, which is M74. And interestingly, this M74 is a galaxy that's sometimes called a phantom. That sounds very mysterious, doesn't it? M74. And let's do a reset over here in the display histogram. And then let's do our plate solve and resync. So Tim, glad you're there with us. If you hadn't commented, I think it would be a very quiet night. Uh, Starry, starry night. And so what our SharpCap software is doing, again, like I told you before, it is now comparing the image that it sees through the scope with the image that it thinks it ought to see. If we were going to go look at M74, you can see we were 3/100ths of a degree off. And what it's doing now is recentering us on that target. And this little doubled up image that you can see, that's all the farther that our mount was off. And I think that's pretty amazing that this telescope mount is that exact, that it can come that close when we fly across the sky to try to find a new target. And that's all the adjustment that our plate solving software had to do in order to help us see. Now you can see we're adjusted, so we'll do one more reset of our display histogram. We've changed our name, so now we're ready to start live stacking. I'm going to go down here and pin this menu up again. Well, I don't see much of anything there yet. Do you? Wow. We're going to reset that histogram and do an auto stretch on it. Wow, I still don't see much. Then we're going to do a reset of the colors, and you pretty much have to let, wow, did we not clear this? Yeah, we didn't clear that out. Let's start this again. That's what that little warning was doing last time. It was saying, you are not going to be able to make head nor tails out of this until you clear the stock, you ignoramus. Tim says, beware the phantom of the night sky. And then he says, of course, Starry Starry Night is not about the sky, but about paintings and the painter. Go figure. Yeah. Oh, I can see it now. Look, that's going to be our M74 up there, I think. So let's wait and let it get one more stocked frame. Once again, oh, look at this. This little trail you see here is a satellite that crossed our frame, or maybe yeah, I'm guessing it's a satellite. Let's do, why don't we do one more live stretch since we weren't live stretching on the correct set of frames. Let's take this white and just get it out of our way for a minute. And let's put this black over here now to actually, are you guys looking at the right thing? Yeah, you're looking with me. Now we can start to see a little bit. Boy, it's a shame. That's going to mess up our, let's leave it in there. It's a nice artifact. Look how when we bump our mid-levels over there, you start to get this sky glow, don't you? I'm going to just look outside. Yeah, see, I can pretty much tell when the telescope is pointing in the direction of Louisville because it's a little pickier with this night sky glow. Let's take this and get a little bit away from that. Ah, that almost took it out, didn't it? And let's move this away so we get rid of that night sky glow a little bit. You know, we probably don't need all these whites here. Because look, there's nothing happening in that part of the picture. Huh. Not a lot of M74 to see, is there? Now let's do a zoom in and start looking at what we can see. Oh my goodness, it's a grainy. We're getting some noise there, aren't we? Wow, we zoomed in too tight. Let's start with 25%. There we go. Now we're able to see. Oh, it's coming in after all, isn't it? Let's come into about 33% or maybe even 50% and start zooming in. Look at the way we can see a spiral arm already. And that's a very noisy sky. You know why that's noisy? I'm having to put our gain on 200 if we want to stay at 30 seconds. I don't know what would happen if we back that down. Let's try it. Let's back that down to 100 and just see what these pictures become. Because that is a lot of noise. Oh, that is better, isn't it? Look at that. You know, this camera likes 100 gain. That is its favorite setting. Now let's pull this black and get as much of the sky as we can. We picked up a little more noise. I'm going to hold down the shift key, and that'll let me have a little more granular. Some of that noise is coming from these mids. Let's get those mids away for a second. Let's just move those out of our way. And let's just focus for a second on what does the night sky need to look like? How much glow can we put up with in the night sky? And I think that's okay. Let's put up with a little bit more. Now let's bring our mids in and see what we can see in this galaxy M74. Let's zoom in a little more. That's 50%. Let's get up into, that's pretty good. Now, while that's live stacking, boy, we're getting good guidance. Our tracking is working well on our map. Jeff says, well, hello from Montana. It's been fun to watch. It's good to have you here, Jeff. Thanks for stopping in. We're going to go now over into our, tell you what, why don't you guys keep watching that stacking, and I'm going to go over to our Planetarium program and find M74. And what I'm going to do is play that audio tour. And you know, to play that audio tour, it really helps if I bring up your desktop audio and mute me.
M74 is a wonderful galaxy in Pisces the Fish. Photos show a very beautiful face-on spiral galaxy. Yet M74 is frustrating to observe. It has a very low surface brightness. Initially, it was believed to be an unresolved globular cluster. Only later did it become clear that M74 is a spiral galaxy. This object is visible as a bright patch in the sky, even in smaller scopes, but a low power is desirable, for, under too much magnification, the tendency is to sweep by the object without being able to see it. Observers have been frustrated in first spotting M74 in binoculars or a finder scope, but when turning the bigger telescope, being unable to see it in the eyepiece. The best cure for these ills is not advice, but practice.
Wasn't it interesting that even as I tried to see it, we lost it. I thought that was interesting, wasn't it? Let me mute that desktop audio again because that does make a funny. Where did the thing go? We lost it, didn't we? I guess our color balance got. Let's do our color balance again. Let's do that on these. Let's get some more of our. We're picking up some new. So is that it right there? Well, it sure did vanish, didn't it? Let's go up and grab it again. Yeah, there we go. You heard the guy say, it's frustrating in the night sky because you can sweep right past it. And the very time he was saying, you can sweep right past it, I did. Now we're finding it again here. Kind of got to zoom in on a little bit at a time or else it's really easy to lose. It is such a tiny dot, isn't it? Look at that. You can see how in a smaller scope, you would just brush past it. Look at that. That's our full res now. And you can see I could doctor up that focus a bit, couldn't I? That's just going to bother me all night long until we adjust that focus. Do I dare go to the trouble of going out to fix that? Wow. I think we ought to. Boy, I cannot wait to get that motorized focuser so we don't have to do this, but I am very tempted to go out and try to fix that, guys. Let's do. Let me put on my. Let's put on my little headlamp, and what we're going to do is we got to unplug the scope cam because the cable for the scope cam doesn't reach out to the all the way out to the telescope. And then I'm going to put on my coat. Now, I focused this thing with a Botanoff mask, and I zoomed in on Capella, and I used the, I don't know if I'll drop out audio-wise, we'll try. I used the tool that's built into SharpCap, the focus aid that's built into SharpCap with the Botanoff mask. So I did the right things, but every once in a while, not often, but every once in a while, you will get a little shift in focus. Now, I noticed this telescope does better than most. Okay, so I'm out at the scope now, and I'm going to go a little bit to the left, and then we're going to watch again and see what happens. You got to wait 30 seconds every time you focus, see, because it's 30 seconds later before you see what you just changed. You know what else? We've got all those stacked frames. I wonder if we're even going to be able to tell that we changed focus. With all those frames being stacked, we might not be able to tell, huh? Well, I don't think we improved it any. So let's go back to the right, and then let's try going back. Let's go to the right again, and let's see if maybe we went the wrong direction first time. We are zoomed in very close. Boy, that is the skinniest little patch of That is the skinniest little patch of galaxy, isn't it? Oh my goodness, we're starting to get some better detail, aren't we? Look at that. Now that's due to the live stacking. It's still got a little bit of sky glow in there from the city, but we'll try to. We are zoomed in so close, so I don't know if our focus is if we're gonna be able to improve it or not. I might be messing it up more just by messing it. Like I say, I did try to tune it with the Botanoff mask. The Botanoff mask is a little shield you put in front of your scope. Well, I don't think we improved it much. Do you guys? I don't think we did any good. And let's go back out to auto. At full view, those look sharp, don't they? Those stars look like pinpoints. It's only because we're zoomed up like crazy so we can see this galaxy. Oh, now I've lost the galaxy again. That we can. It's only because we're zoomed in like crazy that we're revealing this focus issue. Oh, now I've lost it. Where was it? I'm out here at the telescope, and I don't think we're gonna. I tell you what. Let me see what other focusing tools we've got here. Focus assistant, histogram range, brightness detection. There are several other ways we could try. Huh. Let's try. Nah, let's don't. I'm not going to experiment on you guys while we're out here. Let's just assume that that's the best we're going to get it for now. Let's go back in one more time and just look at stars again. Actually, there are no little donuts now, are there? There are at least little disks. So let's just assume that's because we're zooming in so much, and it's just not as good of seeing. And we'll work on the focus. Live to fight another day. When we get that tool, the focusing motor, that's when next time we do an observing session, we'll have that focusing motor, and that's when we'll play with it, because we'll be able to sit here in the truck and adjust it that way. So now what I'm doing, I'm moving all the cabling back inside the truck again, trying to roll up the window just high enough so it doesn't trap the cable much in the window. And what I do is I rest the Tim. Tim had to take off there. He's got something else to focus on. Oh, Tim, it's always good for a joke, isn't he? Uh, let's see. Here we go. Now we're back. I rest the laptop on the little console in the center of this expedition, and then I sit actually in the back seats, and that gives me a little more space to work. We just get everything arranged. Several cables here. We actually have going on. Okay, now let's go back out to our full field one more time, and let's set our dark level again. There is that galaxy. So now let's zoom in one more time, just get one more look at him before we save a snapshot of him. He was over here. Right there he is. Boy, he is a tiny guy, isn't he? But you know what? We're seeing spiral arms. Look at that spiral arm there. There's just not a lot of brightness there, but we are at least seeing spiral arms. I wonder if I'll just dial up that brightness a little bit, if we can eke out a little more of him. M74. M74. And this M74 is in the constellation Pisces. Oh, you know what? It has the lowest surface brightness of any of the Messier objects. Huh. It is the absolute lowest. So it's no wonder that we're having to dial this thing in, huh? Let's go let's go back here and get just a little more darkness in the night sky. And then let's go here and dial that up just a little more. Wow. We're at the limits of Louisville light pollution. But man, you can see that arm throwing out material. It's the grand design, like it said, the grand design galaxy. So you've been able to see M74, and you've seen now the faintest object in the Messier list of galaxies, the faintest of all. So let's save a picture of that. M74, waiting for the next frame. Got it captured. So let's stop the live stacking. Let's go back to our targeting software again and do a new observation and say the faintest of all Messier objects looked faint. But we saw the spiral arms. Want to come back when I can play with focus more. Try to get that a little sharper sometime in the future. Let's go grab that now from its M74 right there. Oh, there's M74. And then we're ready to roll.